About the ways that I do factoring. I was telling the other classes about this earlier. I'm a bit of a traditionalist when it comes down to factoring. I kind of like using the I don't want to say old-fashioned way, but I kind of like using the same method over and over again. That way it's not kind of making you think of all these different things you can do. I know that there are multiple ways of factoring. Okay? I know that some of you guys learned how to do things via that box method. Some of you guys did it, the reverse lattice stuff. Some of you guys do it the way that I have. Some of you guys, there's a bunch of different ways of going about it. Guess and check is out there also. Mr. Tame's he likes guess and check as well. I like to set these things up all the same, because if you set them up all the same, you always have a basic way to fall back on. So here's what I do. What times what is negative 28 that you add together to get negative 12? When I write these out, I make that little chart. Negative 14 and negative 2, those would be the terms, but it'd be negative 14 and positive 2. See why? Because I want a negative product and a negative sum. So I use negative 14 and a positive 2, that works. So the shortcut, if you will, for factoring when your leading term coefficient is just a plain old boring 1, which it is in this case, is all you have to do is write out parentheses, x minus 14, x plus 2. And those in the parentheses are called your terms. Those are your factored terms. Okay. What's different between a term and a 0 is the following. If you see equals 0, it's asking you to find the answer, the solution, the 0. If you don't see an equal 0, it just says factor. You leave it in its terms. We spend a lot of time when we get to polynomials working with factored terms, because we'll be able to write 6th degree polynomials from their zeros. We'll be able to do synthetic division to find intersections. We'll be able to do a bunch of stuff. Okay. Now, if I throw in that equals 0, what would be your zeros of the factored form? Good. 14 and negative 2. So that's stuff you guys have all seen. I just want to remind you, I'm going to change the vocab of it. I'm looking for the terms. Those are what's in parentheses versus the zeros. Also, the other thing you're going to find out a whole lot with this book, they change the variables all the time, from x's to y's to w's to r's to p's to s's to t's and back and forth. It's annoying. I hate it. I will probably always use just x's. I would, if you say, but it says w squared, I'm like, whatever. All right. X squared plus 4x minus 21. Same idea. Yeah. What times what is negative 21, but you add it together to get a positive 4. 7 and 3 are your numbers.
7 and negative 3.
But I want to look at what are the values. Be 7, positive 7 and negative 3. Do everybody agree? Yeah. Okay. So you have x plus 7 and x minus 3. Now, do you guys remember how to check to see if you are right?
No. Foil.
Yeah, foil it.
Foil.
What does FOIL stand for?
First, outer, inner, last.
Let me introduce you to somebody. First, outside, inside, last.
Wait, it's a person.
It's Billy Binomial.
Billy Binomial. Hi, Billy Binomial.
Figure out insanity.
That's Billy.
Billy has one wide head.
He's got crooked teeth.
Oh, please stop.
Oh, yeah.
That's not.
I think we should go further.
I think we should draw.
Give them a glove that says like number 1 is the Bears on it because they won last night.
No, the Packers won yesterday, too.
Yeah, but they won really well.
He has a flag. A foam finger, okay?
That's what I said.
Give him a bow tie.
A bow tie.
Isn't that what I said?
Give him a bow tie.
You a bow tie.
Bow tie.
I think it's backwards too, isn't it?
I don't know.
Nah, whatever.
Give him a bow tie. No bow tie.
This gets boring.
Oh, here we go.
I don't know how to do this. You just
Oh,
T-Rod.
wait.
J-Rod.
Why?
L-Rod.
Why not?
YOLO.
It's just sometimes when you see an equal sign, just the only thing you gotta remember is what are you gonna find at the very end? The zeros. You're gonna find the zeros on your left. Okay. In this case, it just says y equals instead of equals 0. Yeah, it means the same thing. You'll see it in, what's that? Yes, you do. You'd be surprised. Let me ask you this. What is the first rule of factoring? No.
GCF.
Yeah.
Oh, it's just like that.
So yes, greatest common factor. Is there a GCF here? So you factor out the 2 to start with. We okay with that?
Yeah.
Now, can I just factor what times what's negative 12? They add together to get negative 1?
What?
3 times negative 4. So we have 2, x plus 3, x minus 4. Now, I'm looking for my solutions here. I'm looking for my zeros. Does that 2 that we factored out have any bearing upon the zeros whatsoever? No.
But you have to keep this in there.
That's what I'm getting at here. Do I have to worry about this 2 when there's an equal sign? No. It's 2 times all that junk, right? How would you undo times? Not subtracting.
Divide.
So even if I divided both sides by 2, it's still 0, right? Yeah. Doesn't matter. So what are your 2 solutions then?
Negative 3 positive 4.
Negative 3 and 4. Good. It's not the end, it's the 0. Remember what you're doing here is you're setting both of these guys equal to 0 to find the, you set both terms equal to 0. What you're trying to do here is how do you make this equation equal to 0? You set both those terms equal to 0 together. Okay. And the reason they have a y equals there as opposed to 0 equals, it's just sometimes they say 0, sometimes they say y. That's all it is.
Why did the y change to 0?
I just said that. Sometimes they do it, and sometimes they have a 0, sometimes they have a y. That's that. That's all. You will see in the instruction, it'll say solve for the zeros, solve for the solutions, and it might say y equals, it might have a 0.
I
don't know what's so funny.
Above your red looks like my blue.
Guys, listen. I'm right in front of her, I can't even hear her. What?
We ever give us questions how to test the wall temperature this time?
Oh, yeah. Absolutely. Which means you have to remember how to do
More backward.
this.
Oh, that's a bus. No, it's not. I lied.
That's cold.
We'll jump right to the leading term coefficient not equal to 1. And there's no GCF. Okay. Now, just like I did earlier, when we had the, let's say it's this, x squared plus 10x plus 25. What's the coefficient up in front of the x squared that you don't see? 1. It's a 1. So in essence, you guys were still doing 1 times 25, right?
Yeah.
The only thing that changes now, instead of it being a 1, it is now, in this case, 3. So you're going to ask, what times what is 30 that you add together to get negative 17? Very good.
Wow, that's like.
So the 2 numbers you multiply together to get positive 30, but yet you add them together to get negative 17, they're both going to be negatives. Negative 15 and negative 2. Okay? All right. Now, this is where I do this a little bit differently than what most people see. Okay? it takes a step further than normal, but it forces you to get the right answer. I do what's called factor by grouping by split middle term. Okay? What I'm doing here is I'm taking the 3x squared minus 15x minus 2x plus 10. What I've done here is I've split that negative 17 into two terms that were the products of the outsides, that make up the outsides. Okay? That's all I'm doing.
That was my preferred method back in algebra.
To me, this is the most sequential, simplest way to do this. All right? Because now, since I have 4 parts, I can group the first 2 together and group the second 2 together. Factor by grouping.
But she just never had us like she never liked to use this.
This is the easiest way to do it. Okay. What's the GCF of 3x squared and 15x? 3x. So I factor out the 3x. I'm left with x minus 5. Now, I chose an example right off the bat where I know that you guys are going to screw up. Look at the third term here. It's a negative. Do you guys see that? What you normally are going to do is you're going to forget that it's negative. You're just going to write down a 2 here. Here's what I want you to do. Anytime your third term is negative, do this right away. And then group it. The reason that I do that is because it forces me to remember real quick that the third term, the 2 in this case, is negative. So I remember to factor out the negative. All it is just a reminder to factor the negative. By doing that, you're making a negative sign, so subconsciously, hopefully, you'll remember that you got to take it back out. That's all it is. It's just a little trick that I do differently to help, because I know where you're going to screw up. You're going to screw that up. So don't screw it up now. Yes, sir.
I'd like to thank Ms. Lahuda because she taught me to do it the exact same way you did.
Wow.
I'm
Yeah.
proud because I did it right. I did this out.
So my factor out, I'm kind of making this a dead giveaway here that the GCF here is going to be a 2, right?
Yeah, I got
So I factor out the negative 2, I'm left with x, and what's 10 divided by negative 2? See how that forces it to get the same terms now?
Yeah.
Are those two things that are in parentheses the same?
Yeah.
If they are, that means you did something right. If they are not, you did
Something
wrong.
I was going to ask to get the negative 2, but I negative 2 and then minus 2.
So now, what I do, since these two guys are exactly the same, I write one of them down. And what's left? 3x minus 2. And I'm done. There's multiple ways of doing this. This, to me, is the way that I learned. Do you guys also notice that I went 15x and then 2x? Could I have gone 2x then 15x? It doesn't matter because the adding is still going to get you the same value. I just happen to write it down that way. Okay? Vaguely remember this?
Yes.
Okay.
I remember she always tried to use this not to do it this way.
This is the most basic way of setting these things up that I can even think of. I'll show you another one here. Practice.
It's not that worksheet.
Let's walk another one together.
All right.
Guys.
Don't yell out the answer.
No, because what you're doing here is you're always going to ask me 3 and 10 to start with, so I get 30. So you're still asking me what time it is, 30, but it has. Okay. So you're looking at just the factors of 30. Does that make sense? Yep. Okay. I'm hearing a lot of people say the right way of doing this. That's good.
Oh, found it.
I'm gonna mess you up real quick. I'm gonna make you do this though. Please don't.
Oh, I see.
All right. I'm just gonna ask you. Oh yeah, the calculator. Yeah, the non-calculator part you guys just had was kind of like a gimme. Smiley face, triangle. That's awesome. The look on your guys' faces when you first saw that, and all of a sudden some of you guys turned around and looked at me, like. Then he started laughing. I'm like.
Lincoln, don't make fun of me. I put 2 smiley faces.
6 and 1.
We agree it's 6 and 1?
Yeah.
I do.
Show no, but in high school.
What's the play?
Does it matter if I put the 6 first or the 1 first?
No.
Makes no difference. For 1 million points,
Million points, pretty good.
what property? What property allows you to add either direction?
Community.
Who said that? Colton gets 1 million points.
Yes.
I think he's gonna win this one, guys. I don't know.
I think.
I think we lost.
Let's go. We just don't go back. I feel
Now, in that secondary group there, do they have anything in common, the 1x and the 2?
No.
When they have nothing in common, what do they always have in common?
One.
Is this like our homework?
Maybe.
Yes?
Or is there like another part of
It could be whatever you want it to be.
What are your zeros for this function?
-2.
-2 and?
Negative.
Very good.
Hooray.
-1/3. How do I get the zeros? I set both of the terms equal to 0 and solve for x. So I said,
Hey, it's not Mr.
says you. Hey, don't mess around. Really?
I wanted my million points, man.
I know. You'll get there. So to get the -1/3, subtract 1, divide by 3. All right, and those are your zeros of the function.
Yeah, all right.
All right. Now, the other stuff that we're going to see in here takes us back the other way to that.
Oh my gosh, is it square stuff?
What's that?
Perfect square?
Completing that square.
We're not completing the square. It's not a perfect square.
It's the
Make a
difference of
square.
square.
It's the difference of
Do I
squares.
get points?
No.
3.
Hey, that's better than nothing.
Three more than all of you. Except
Now,
for Colton.
how many?
Three more than
His adding skills might not be
It's okay, just not a smile. Now, in this case here, it's x squared minus 49. There's only 2 parts to this problem. There's no x term. Everybody agree?
Yes.
All right. So this, yes, this is the rule that happens here. When you see just 2 terms, you're going to ask yourself 3 very simple questions. Is x squared a perfect square?
Yeah.
A perfect square means is it made up by 2 numbers that are the same?
Yes.
X times x is x squared. So yes, yes,
You
sir.
adding equals to it?
No. Now, is 49 a perfect square?
Yes.
What's the square root of 49?
But it's negative.
Now, oh, I'm not done. I've only had 2 questions. Relax. Once again, is this a perfect square?
Yeah.
Is this a perfect square?
No.
Yes.
Yes.
I'm not asking about that. I'm just asking about the value. Because can I ask the third and final question? Is this a subtraction symbol? Yes. Did you say yes to all 3 of those questions?
Yes.
Okay, what's the square root of x squared? What's the square root of 49?
7.
Okay, 7.
That's what you call a difference of squares. The 3 questions you have to ask when you see 2 terms are the following. Is the first one a perfect square? Is the last one a perfect square? And is it a subtraction symbol between? I'm not worried that it's -49. All I'm looking at is just the term itself, x squared and 49, because the third and final question is,
Minus.
if you can say yes to all 3 of those things, that's your solution. What if it's positive? Great question.
I got points for that.
Reading this.
No.
We are not completing the square here. Now, if this is positive, let me walk you through why this does not work. Is x squared a perfect square?
Yeah.
Is 25 a perfect square?
Yeah.
Okay. Now, what you're thinking here, since this is an addition sign, I can't do the plus minus thing. Because if I expand this out, can I say it is x squared plus 0x plus 25? Does that change that at all?
Yes, it does. Nope.
It doesn't change the value though, because 0 times x is still 0, right?
Yeah.
So what in essence you're going to ask yourself is, what times what is positive 25, but when you add it together you get 0. You can't. There is nothing. There's nothing until next week.
Wait, both.
Imaginary numbers.
Oh, yeah. Those numbers. That's
Actually, on Thursday.
I know that, Lincoln. That's like finding the same.
We can explain that theory. Let's tell the guys. Give us a.
Try that one. Try this one out.
I don't know what that is. 144.
It's not a trick question. That's a good day too. Okay. Why did it come out like what? Did it come out like this?
Yes. Yes, yeah.
That's a perfect square. That's called a perfect square. No. Now, what's that? Now, what's going on in this case here, there's a couple of things you can do. You can multiply it out the long way, which is fine. Or, some of you guys might recall patterns from a long time ago. Here's what I mean. Is this a perfect square?
Yes.
It's 3x, right? Take square root of that?
Yeah.
Is 16 a perfect square?
Yeah.
Okay. What's the square root of 16?
4.
What's 4 times 3? Double it. Here's the reason why I don't go with the patterns. The reason I don't go with the patterns is because, remember when we did that quick times table test and I scared you guys a lot?
Didn't scare me. I laughed. You made me cry.
What happens is a lot of times, I think some of you guys might have, we've talked about this already, that some of the number sense quick pick things that you guys weren't brought up doing. That shortcut division, how I was showing the shortcut division with the fraction bar, you guys kind of like, things like that. It's okay. If you don't recognize the pattern, it's not a big deal because you fell back on 9 times 16, you got 144, so you had 12 and 12. And all you did was group it, right? And you grouped it out and you got the same answer. So, to me, I don't believe that there's that big of a deal to have to recognize it right away. I mean, you can take a guess that it's going to work when you see it, but there's no reason for us to memorize and try to remember all the different scenarios of the formula like that, because it's kind of pointless. Okay? Just my own opinion on that one. You can always fall back on the rule. And what I mean by the rule here is talking about going back to the zeros, or the factory, outside terms. Okay? It always works, the factory by grouping. It'll always work, unless we have to complete the square stuff. What's that?
Why do you get us like a...
Oh, do you have it like this? 3x plus 4, 3x plus 4?
I can correct this.
Oh.
Do you have it like that? When you're multiplying the same thing twice, aren't you squaring it? No, we're not killing puppies here, correct? We're not killing puppies.
That's what Mr. Sev says.
He's right.
Now, why were we killing puppies?
We're not.
Why does not even
Because when Seven talks about killing puppies, he's talking about getting 9x squared plus 16. Then you killed a puppy. Not 3x plus 4 quantity squared is junk squared. Junk squared is junk times junk.
No, we were just guessing.
Solve this one, please.
The logic is so confusing.
Solve this one, please. It's like 20 after.
10 after.
Whatever. That's close.
I get points because I corrected the teacher.
You get negative 4.
Yeah. Well, after we do this one, I'll give you guys some props.
I don't have a problem.
This is golf.
I know what you're doing.
I wrote my side. I missed that.
Did you get the negative 3x and the negative 5x in a little bit?
Yeah.
I did that wrong.
Of course I did.
What we're doing, we want to go positive 15 to add a negative 8.
Yes, sir.
15 only has 4 terms, 1, 15, 3, and 5, so 3 to 5 work.
It's bound to be
Well, I happened to get that before I could say 3 and 5. I was still 115.
Okay?
That means you're losing.
Now, from here, group them. GCF, the first set is 3x. When you factor out a 3x, what are you left with inside your terms then?
X minus 1.
X minus 1, good. What am I going to take out for the second set? Negative 5. Take out the negative 5,
And then it's X minus 1.
then I'm left with x minus 1.
Yes, I did kill him.
Okay?
Yeah, I got that.
Now, it is the same thing in parentheses. Did you did you write down the 5x first and then 3x? You're going to get the same answer. Because when you're done, you get dun dun dun. X minus 1.
And then 3X minus 5.
When you do minus 5x,
And then you gotta solve for the equation.
Yeah, if you do minus 5x first, you get this. 3x squared minus 5x minus 3x plus 5. If you do that, take out the x, you have 3x minus 5. Here you take out the negative 1, you have 3x minus 5. You see how you're still going to get the same, you'll still get the same 2 terms. Yes, sir. I know, I'm not done yet.
Okay.
But wait, there's more.
infomercial.
It slices, it dices it. Now, what are your 2 zeros?
Negative 5.
Ah, is it negative 5/3 or positive 5/3?
Yeah.
Why? Remember, what I'm doing here is I'm setting both terms equal to 0. So I just move the 1, then I add 5, divide by 3.
5/3.
I'm solving for yeah, whatever you're finding zeros, you're just... What's up?
Why did you write equals 1?
Oh. I did that earlier too. I'm sorry, it's supposed to be 0. I was already saying the 0 was 1, that's why I put there. I'm sorry,
That
thank you.
makes sense.
Sorry, I did that earlier today too. I'm sorry about that. We knew the 0 was 1 and I automatically just wrote 1 instead of a 0 there, so. Okay. Here's what I want you to do tonight. It's section 5.2. I believe it's 260. Where's my book? Let's see. Numbers.
Number 1.
22 through 86. Every other evening.
I was about to cry. Oh, thank you.
I believe it's 17.
I would have been saying 2.
Is this for
I was like,
every other? Then you write down every. Because it means section.
oh, yeah, like you didn't just even though it's not.
I didn't forget.
Every other
Oh,